Hello students, how are you all? Today I am here to finish up the remaining part of the chapter Gravitation. So let's begin. Today's first topic is free fall. We all know that all the objects on Earth is attracted towards the center of the Earth due to gravity. So when an object falls only under the action of gravity, we call it free fall. Due to the force of attraction, a body falling from a height undergoes acceleration, and this acceleration is known as acceleration due to gravity. It is denoted by g and its unit is meter per second square. Now we are going to learn about acceleration due to gravity and ways to calculate it. Acceleration due to gravity is a constant. That means it is irrespective of the mass of the body or the height from which it is falling. Its value remains constant at 9.8 meter per second square. Now let us see how to calculate it. Let us consider a body of mass m which is placed on the earth of mass capital M and radius r. We can see the picture of our earth. Here is the radius of the earth and this is capital M is the mass of the earth and this small m is the mass of the object that is on earth. So by universal law of gravitation we know that F equal to g capital M into small m by r square. Here g is the universal gravitational constant. In the same way, by applying the formula of force, we can also find that F equal to m into g. Here g is the acceleration due to gravity. From the two equations we can conclude that small m into g is equal to gmm by r square. By cancelling this m, we can find that g equal to gm by r squared. Here, as we all can see, g is a constant, mass of earth is a constant, and radius of earth is also constant. So from this equation, we can see that the value of g will also remain constant. And by putting all these values, we get that g equal to 9.8 meter per second square. Now we are going to learn about mass and weight. Mass of a body is the measure of its inertia. That means the more mass it has, the more tendency it has to remain in its state of rest or of uniform motion. Mass of a body remains constant and it does not change from place to place. That means I can change the position of a body, but its mass will remain the same. The SI unit of mass is kg. Now coming to weight, if we multiply the acceleration due to gravity with the mass of a body, we get the force with which the body is attracted towards the center of the earth. This is what we call weight. So weight is a force, therefore F equal to m into g. We denote weight with W. Since g at a place is constant, since acceleration due to gravity is constant, weight of a body is directly proportional to its mass. That means more the mass, more will be the weight of a body. Since it is a force, its unit will be Newton. The weight of a body changes from place to place since acceleration due to gravity changes from place to place. Now, if we go to the moon, the acceleration due to gravity of the moon is 1/6 of that of the earth. That is why the weight of a body is also 1/6 of its weight on earth. If a certain object weighs 60 Newton on Earth, its weight will be only 10 Newton on Moon. Here are some differences between mass and weight. Mass of a body always remains constant. We have learned it from the definition. And weight of a body changes from place to place due to the change in acceleration due to gravity. Mass of a body is never zero, but weight of a body at the center of the earth is zero, since at the center of the earth acceleration due to gravity will be zero. Mass is a scalar quantity. That means it has only magnitude but no direction. Weight is a vector quantity. Since weight is a force and it is associated with both magnitude and direction, it is said to be a vector quantity. Mass is measured in kg and weight is measured in Newton. Students, you can pause the video and write down the differences in your copy. So, this is the end of today's discussion as well as the end of the explanation of the chapter Gravitation. I hope all of you have understood the chapter properly. NCERT and exercise questions will be provided in your school website. We'll see you again with the explanation of a new chapter after some days. Take care.